In this video, we'll talk about the total number of outcomes in probability. So probability is given as number of desired outcomes divided by total number of outcomes. And the numerator is always a subset of the denominator in probability. Meaning, if the total number of outcomes are, say, the items in the total number of outcomes are 1, 2, 3, 4, 5, and 6, then the number of desired outcomes must be out of this 6 items, right? It cannot be outside of the 6 items. So that's very important. So this means the content in the denominator will dictate the content in the numerator, right? Now there are two ways of calculating the total number of outcomes. One is counting only the unique combinations, and the second is counting unique combinations as well as their possible arrangements. So let's say if there are 5 people, A, B, C, D, and E, and two are to be selected, so the unique combinations will be 5C2, right? Now, if the question is select 2 people for 2 different posts, right, like post of a manager and a director, so that would require a combination of any 2 people, yes, and also arrangement of those 2 people, right? Because after 2 people are selected, they can be any one of them can occupy either of the posts, right? So there are 2 factorial ways in which they can occupy the 2 posts. So this is your combination as well as arrangement. So actually, for more details on permutations and combinations, do refer to the videos and reading resources on it. So let's see how we can use this in probability. So say there are 4 red balls and 3 blue balls. If 2 balls are picked at random, what is the probability of picking 2 red balls? Now, calculating the total number of outcomes using the first method, counting only unique combinations. So there are 7 balls basically, right? Let's say R1, R2, R3, R4, B1, B2, and B3, right? These are the 7 balls. Now 2 balls are picked at random. So R1 and R2 are picked, or R2 and R3, and so on, right? So counting only unique combinations would mean that you're only interested in this unique combinations. You're not interested in uh, the order in which they are selected, right? So this is 21. So there are 21 unique combinations of 2 balls. Now, the other way of doing this is finding the unique combinations as well as their possible arrangements. So this is, so basically there are 7 balls, right? So any one of them can occupy the first place, right? Now we are left with 6 balls. So any one of the 6 can occupy the second place. So the total number of arrangements is 42. So this is another way of counting all the possible outcomes. So in this case, R1 and R2 is counted, R2 and R1 is also counted, right? In this case, whereas in the previous case, only this combination is counted. Only this meaning either of the one combination is counted. Both the combinations are not counted. Basically, the order does not matter. Does not matter here. Whereas in the second one, the order does matter. Now, take another example. So there are 4 red balls and 3 blue balls. If 2 balls are picked at random, what is the probability of picking a red ball and then a green ball? So in this case, we have to first pick a red ball and then a green ball. So clearly the question suggests that the order does matter, in the way you pick up. So in this case, we cannot use this. Counting only unique combinations, we cannot use this because this does not take into account the order in which the balls are picked, right? So we only have to use the second option to find the total number of outcomes. So in this case, the total number of outcomes is 42, right, as we saw previously. So that remains the same. Now, if you're interested in finding the probability here, so basically there are to count the number of desired outcomes, the first ball has to be a red ball picked, right? So there are 4 ways in which you can pick a red ball. And then there are 3 ways in which you can pick a blue ball, right? So it's 4 times 3, it's 12. So your answer probability would be 12 divided by 42. Now, in case if the order was not important in which the balls were picked, your answer would be this times 2 factorial. Why 2 factorial? Because this we are assuming it in this given order, right? R and G. But it could have been the other way around, G and R. So R and G can be arranged in 2 factorial ways. So in that case, if the order was not important in which the balls are picked, then your answer would be 12 times 2 factorial divided by 42. Okay. Now let's take another example. 2 dice are rolled. What is the probability of getting a sum of 8 on the 2 dice? So in this case, the total number of outcomes are 6 square, which is 36, right? So if you list down the number of outcomes when 2 dice are rolled, you see that this is one outcome, this is another outcome, this is another outcome, right? So you can get a 2 on the first dice and first on the second, 1 on the second dice, or vice versa. So doing this, counting all of this, you'll get 36 outcomes, right? So let's list down a few more outcomes: 3 and 5, 5 and 3, 4 and 4. Obviously, this is counted only once, right? So now we need to find out the probability of getting a sum of 8 on the 2 dice. So sum of 8 is possible if you get 2 and 6, or 6 and 2, 4 and 4, 3 and 5, or 5 and 3. So there are 5 outcomes, right? So the probability is 5 divided by 36. Take another example. A coin is tossed 3 times. What is the probability of getting exactly 2 heads? So in this case, the total number of outcomes is 2 cubed, 8. So the total number of outcomes is, so let's say you get all 3 heads, or this combination, or HTH, right? Or HTT, and so on. So this is how you get 8 outcomes possible when when a coin is tossed 3 times, or when 3 coins are tossed. It's the same thing. So in this case, we need to find the probability of getting exactly 2 heads, right? So the probability of getting 2 heads would be when you have HHT, right? Or HTH, or THH. 3 outcomes. So the probability is 3 divided by 8. In some other videos, we'll see how to calculate the numerator, right? The number of desired outcomes. There is a trick to calculate the number of desired outcomes.